Hello, in this video, Gray Wolf optimization algorithm is discussed. Topics that are covered in this video: what is Gray Wolf optimization algorithm, who are the Gray Wolf, how this algorithm works, mathematical model of this algorithm and its flowchart. Then we will try to explain this algorithm with an example. And then we have the application of the Gray Wolf optimization algorithm where it is used. So what is Gray Wolf optimization algorithm? It is a meta-heuristic proposed by Sir Miraj Ali and Lewis in 2014. Here you can see we have a new word, that is meta-heuristic. So what is meta-heuristic, or what is heuristic optimization? Meta-heuristic means it's a high-level, problem-independent algorithmic framework. Where this framework is used, it is used to develop optimization algorithms. And these meta-heuristic algorithms find the best solution out of all the possible solutions of an optimization. Gray Wolf optimization algorithm is also a meta-heuristic algorithm. It is inspired by the social hierarchy in the hunting technique used by Gray Wolf. So in order to understand this algorithm, first we will discuss who are the Gray Wolf and we will understand their hunting techniques. It is an animal, obviously. It is a large canine like this. Speed is up to 50 to 60 km per hour, and the lifespan in the wild is 6 to 8 years. And they belongs to a Canidae family, that is the biological family of the dog-like carnivorans. And you can see here in the table we have the weight, length and height of the male wolf and female wolf. Next we will discuss certain features about the Gray Wolf. They live in a highly organized pack and they are loyal to the pack members, and they are the most successful animals on the earth. How? Because they are able to survive in a variety of different climates. One important thing that is important for their survival is the ability to work together in a pack that increase the chance of success during hunt. And in a pack of wolf, they have dominant pack leaders. So it is done that they live in a highly organized pack. In the pack size is 5 to 12 wolf. 4 different ranks of the wolf in a pack are Alpha wolf, Beta wolf, Delta wolf and Omega wolf. Now we will discuss about Alpha, Beta, Delta wolf, and we will understand their role in the pack, because this algorithm, that is Gray Wolf optimization algorithm, it is based on the social hierarchy in the hunting technique of the Gray Wolf. Next, first we will start with Alpha wolf. That is the leader of the pack. It is a male and a female. Rest of the pack member follow the alpha, and the responsibility of the alpha wolf is to make decisions about hunting, sleeping places and time to wake up and other important decisions. Beta wolf is the second level of Gray Wolf in the hierarchy, and they are the best candidate to be the Alpha wolf. They help the alpha in decision making and other pack activities. They also give feedback to Alpha wolf. Next is the Delta wolf. If the wolf is neither Alpha, Beta or Omega, then the wolf is Delta wolf. And Delta wolf dominate Omega wolf, and the role of Delta wolf in the pack is they provide the food to the pack and they work for the pack in case of any danger. Next is the omega wolf, that is the lowest rank wolf. As you can see here, omega wolf play the role of scapegoat, that is the victim who is blamed for the mistake of other. And in this category we have scout, elder, hunter and caretakers. Scouts are responsible to watch the boundaries of the territory, and in case of any danger they will alert the pack. Elder are the experienced wolf, and they are the best candidate to be alpha and beta. Hunter, the role of hunter in the pack is to help the alpha, beta, delta wolf during hunting. Caretakers take care of weaker wolf or the injured wolf during hunt. Whole the grey wolf pack face internal fighting and problem in case of losing the omega. Next, we will understand how grey wolf optimization algorithm work. So in order to understand this algorithm, we will understand the hunting behavior of the grey wolf. Because this algorithm, that is the grey wolf algorithm, it mimics the leadership and hunting mechanism of the grey wolf. So we have certain steps that are followed by grey wolf for hunting. First, searching for the prey, tracking, chasing, approaching, then they will encircle it and harass the prey until it stops moving. And the last step is attack. So first we will see how we will search, track, chase, encircle and attack. Then we will convert it into a mathematical model. Example of prey that grey wolf target is white-tailed, mule deer, moose, caribou. Now we will start with step 2, that is how grey wolf hunt. Once the target is entered in the territory, that is the wolf territory. Now what is territory? It is an area defined by a group of animals against other. So once the target is entered in the territory, the pack will chase the prey to make the kill. They will select a weaker one, weak target or the prey, then they will chase it to make the kill. They will chase the target to the other waiting wolves, and you can see here they encircle the prey. Now how we will convert this into mathematical model? For this we will consider the fittest solution is alpha, second fittest solution is beta wolf, third fittest solution is delta wolf, and omega wolf follow the 3 wolves. Now encircling of the prey is modeled as vector D is equal to this and this. Here D is the distance vector, T is the current iteration, XP is the, here you can see this is the position of the prey, X is the position of the grey wolf, A and C you can see here they are the coefficient vector, and we will calculate the value of A and C using these two equations. Here you can see R1, R2. R1, R2 are the random vectors and range is 0 to 1. Vector A you can see here it is a component that is linearly decreasing from 2 to 0 over the course of iterations. So it is clear that the above equations you can see here they are used to update the wolf position according to the position of prey, and different places around the best search agent can be reached with respect to the current position by adjusting the value of A and C. How we will adjust the value of A and C? Using these two equations. And then here you can see R1, R2, these are the random vectors, that allow the wolf to reach any point between the two particular point. R1, R2 allow the wolf to reach any position between two particular points. The third step is grey wolf hunting. Grey wolf hunting starts by locating the prey. Once the target is entered in the territory, they will start chasing it, and when the target is confronted, it starts moving, that is running away from the wolf, and it gives the chance to the wolf to make hunt. Now here wolf will target the bigger one or the elder one according to their bigness. They will target their prey. Then they will chase it to make the kill. Now large animals like moose may stand their ground and fight. You can see here. Suppose we have a larger animal and that is willing to fight. In this case, wolf may choose to try other prey rather than risk attack on a large animal willing to fight. Because now mathematically, hunting process is guided by alpha, and it is assumed that the alpha, beta and delta have better knowledge about the location of the prey. That is the optimal solution. Other wolf in the pack will update their position according to the position of alpha, beta and delta. Now this is the grey wolf hunting. Mathematically we will use this, and then we will update the position of the grey wolf by calculating the mean. Here x alpha, x beta, x delta are the position vector of the alpha, beta, delta wolf. That is the position of alpha wolf, beta wolf, delta wolf. And these are the coefficient vector, and always keep in mind that coefficient vectors are written in column. Last step is killing prey. Alpha wolf will finish the hunt by attacking the prey, and once the prey has been hunted, the alpha wolf will eat first, then according to the wolf rank in the pack they will eat. So mathematically we will model this as when the prey stop moving, wolf attack it to finish the hunting process. This is modeled by decreasing the value of a from 2 to 0 during the iterations. Now how we will change this? As you can see here, we are calculating the value of a here. As the value of a decrease, this also decrease. Now what is the rule of a here? When the value of a is less than 1, it forces the wolf to attack toward the prey, and if the value of a is greater, it diverts the wolf and they will search another one, the better one. That is the searching is the first step that we didn't discuss. This is the searching for the prey. So this is the wolf algorithm. Let's understand this with the flow chart. First initialize the wolf population, then initialize the values. After that calculate the fitness of the each search agent, and then we will update the position of the current search agent and find the position of the wolf. And then we will again update the values, calculate the fitness value, update the position of the wolf and increase the iteration. Then we will display the position of the alpha wolf. This is the optimal solution, and as we know that alpha wolf attack the prey, so we will display the position of alpha wolf and its fitness value. If it matches the criteria, then we will stop, else we will repeat this until we get the solution. Next, step 1 is initialize the population. Suppose we have 12. Initialize the value of a, c and small a. We will assume the value of small a is 2 because it is a component that is linearly decreasing from 2 to 0. Here you can see how you will calculate the value of a and c using these two equations. Now a1, a2, a3, these values are calculated using different set of random numbers. After that, next step is we will calculate the fitness of the each search agent, and once you will calculate the fitness of the each search agent, after that we will choose the first 3 best wolf and save them as the alpha, beta and delta. That is, the alpha is the best search agent, second best, third best, and it is assumed that the position of these, it is assumed that they know the position of the prey. Right now we don't know the position of the prey, so the position of the prey in the first iteration is the alpha wolf. That is the best solution. Fitness function or the fitness value, that is also called evaluation function. It determines how fit a solution is according to desired problem. And as we told you that we assume the values that the alpha, beta, delta have better knowledge about the location of the prey, so we assume these values have position of alpha, position of beta and delta. In some research papers, they calculated the fitness function using Kapur and Trophy method. I provided the link below. You can see the resources. I provided all the resources in the description box to calculate the fitness value. Next step is update the position of the current search agent by the above equations. Now we will calculate the mean. So for that, first we will calculate this. So first we will calculate distance vector, then the position vector, then we will calculate the mean. For this, first calculate the value of d alpha. Put the values here. C1 is 2, x alpha is 6, here x alpha is 6, this is a mistake please, and we will assume the value of xt is 1, and next step, value of c2 is 4 and x beta is 11 and this is 1. In this case this is 6, not 5, so the value is here now 11. Now calculate the next value, that is here, and update the value this. Next we will calculate the values of x1, x2, x3. We will change this 11, done. Calculate the values. After that we will calculate the mean. Please put the value of x alpha 11 and then calculate it. After that, when you will calculate this, you will got the mean 184, or when you will put the value of x alpha is 11, so according to you, I don't know what you will get. After that, position of the grey wolf is updated. Now we will update, next step is update the position of, update these values AAC. So first we assume the value of A is 2. Now we will update this value using this equation. Here T is the current iteration and this is the maximum number of iterations, and the value of A and C is updated as using these two equations. Then we will calculate the fitness value and we will choose the alpha, beta, delta wolf. Now we will use fitness value and the wolf score. I provided a link again below in the description box for this. So this is how we will update the position of alpha. If it is less than, if fitness value is less than alpha score, then update the alpha position. If fitness is greater than alpha score and it is less than beta score, then update the beta position. If it is greater than alpha and also greater than beta, but it is less than delta, then update the position of delta. Next step is increase the iteration. Now this is the second iteration. Now we will display the value of x alpha, that is the position of alpha. If it matches the criteria, then we will stop. If no, then we will repeat this again. So that's all about this algorithm. And again, I'm telling you that please put the value of x alpha here. As we calculated, the value of d alpha is 11, so please put the value of d alpha here 11, and after that calculate all this. So application of this algorithm is, it is used for solving complex optimization problems, and it is used for optimizing key value in the cryptography, and it's also used for solving economic dispatch problem. And this algorithm is also used for the training of multi-layer perceptron. That's all about this video. If you have any question, you can comment below, and I provided all the resources related to this research in the description box that can help you. And still, if you have any question, please comment below. And thanks for watching this video.